Ladies and gentlemen, boys and girls, children of all ages, we are now going to review day 3 of how to convert in the metric system. We have 4 problems that I asked you to do 73 minutes ago. Some of you finished 4 problems in 73 minutes. Others of you pretended like you haven't been here the last 2 days. Or have no notes in your journal of doing this. So I, being the caring teacher that I am going to strive once again for you to understand. So what I've done in class 1, I recorded me going over these problems with my first class. This is class 2. I'm going to record myself going over these 4 problems with this class. Class 3. I'm going to record myself going over these 4 problems so that we can grasp the concept.
Dramatic grasp.
Now, Ethan, do you have these written down? Or are you participating in school today? Or it would be awesome if you would. I'm just saying. Now, we spoke mostly about the suffix meter. Meter, kilometer, centimeter, millimeter. That is measuring length. Length. Now we move on to, and it's the exact same process, to grams and liters. Gram is our unit. Kilograms are 1,000 grams. There are 10 centigrams in a gram. There are 1,000 milligrams in a gram. It is the same pattern. The same with liters. That is why converting in the metric system is so much easier than converting in the customary system. All it requires is the movement of a decimal point. The movement of a decimal point. As you hopefully recall, we spent, Ethan, if you want to remain in here, then keep your hands off her desk. Can you stop? Because I'll be happy to facilitate that. As you recall, Tuesday, we talked about multiplying and dividing by powers of 10. That's all we're doing with converting in the metric unit, in the metric system. So we're either multiplying, dividing by 10, by 100, or by 1,000. So let's look first at 10,870 grams equals how many kilograms? But we have an issue. Megan, if we're going to move the decimal point, as I observe this problem, it does not appear to have a decimal point. Megan, what should I do? The decimal point goes after the ones place, which is in this number at the end. The ones place is always, and I mean always, located behind the ones place. You learned about ones place, tens place, hundreds place, thousands place when you were 2 months old. We're going to continue to use that information to help us improve in our mathematicas. Now we are going from grams to kilograms. So Megan, which are bigger, grams or kilograms? Kilograms are bigger. So we're going from grams, what we know, to kilograms, what we don't know. So that means we're going to have to divide. This is like a model of a division sign, so you can kind of visualize it. Some movement and actions in it. So we are going to divide, and we need to go from grams to kilograms. So, my young friend Megan, what are we going to divide by? We are going to divide by 1,000. And as my young friend Megan once told me, when you divide, you move to the left. Because we're going from grams to kilograms. Grams are smaller than kilograms, which signifies division, which means we need to make this number smaller. And that means we have to move it to the left. My young friend Megan said we're dividing by 1,000, which means we have to move the decimal point to the left. How many places, my young friend Megan?
3.
You're not my young friend Megan. 3, thank you. So 1, 2, 3. Now my decimal will be between the 0 and the 8, or 10 and 870 thousandths kilograms. You could leave this last 0 off and it's not going to change the value. Got this written down, Ethan? Good. 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 The exact same process. You figure out if you're going from smaller to bigger or bigger to smaller, and then you just have to move the decimal point by the same number of zeros that you have in your multiple of 10. I'm just saying. Next, we have 23 and 5/10 kilograms equals blank grams. Gauge, which is bigger, kilograms or grams? Kilograms. And kilograms is the one we know, so we're going from kilograms to grams, which means we multiply. So we're going from kilograms to grams. So we're going to multiply by what, Gage? 1,000. And when we multiply, we move the decimal point to which direction, Gage?
To the right.
To the right. Because if we're multiplying, we want the number to be bigger. The number to increase in value. So we have 23 and 5/10. We need to move it to the right. How many places, Gage? 3. But oh no, I only have one number here to move it behind. What should I do, Gage? I can't just move it one time.
Or you can add zeros.
I can add zeros. Now I have moved it 3 places. So 23 and 5/10 kilograms equals 23,500 grams. Again, if you use that chart you've glued in your journal, it's just a matter of moving the decimal point. Let's pretend like one day, long, long ago in a galaxy far, far away, you didn't have this chart to use. You could recreate this chart by looking at your formula chart. It would be very easy to recreate. So if you want to recreate this on some sort of state test you have to take where you don't get to bring notes into it, it would be very easy to recreate. Let's look at the next one. Now we're talking about milliliters and liters. Well, milliliters is in the same place on our chart as millimeters. And we have to go to liters. So we're going from here on our chart to here on our chart. Oh, should I call? Addie.
Yeah.
You were worried I was going to call on you, weren't you? Addie. I have to move decimal points in order to do this problem. But alas, I do not visually see a decimal point in the number 217. So, oh my goodness, Addie, what should I do?
There's always a decimal point at the end of the one's place.
Good, behind the ones place. There's always a decimal point, even if it's invisible. It is behind the ones place. You learned that when you were 763 years old. You need to remember that. Now, are we going to, Addie, are we going to multiply or divide? We're going from milliliters to liters.
Multiply.
We are going to
Wait.
smaller to bigger.
Divide.
We are going to divide. Milliliters are small. Liters are big. This indicates division. And Addie, what are we dividing by?
10 and 100, but you can add the zeros together to make 1,000.
Good. We could do two ways. We could change from milliliters to centiliters by multiplying by 10, and then centiliters to liters by multiplying that again by 100. Or we could just do 10 times 100 is 1,000. So we could divide by 1,000. Now, Addie, when we're dividing in our conversions, or when we're just dividing a number by 1,000, period, which direction am I going to move that decimal point?
Left.
To the left. Because I want the number itself to get smaller. So, Addie, how many places to the left am I going to move this?
3.
3 places to the left. So I have 1, 2, 3. So my answer should be 217,000 liters.
Yeah.
Which leaves us with one last problem to work on. I have 8 3/10 liters, and I have to change that to milliliters. It's already got a decimal point in it behind the ones place because the 8 is in the ones place. So now I just have to decide, am I going to a smaller unit to a bigger unit or from a bigger unit to a smaller unit? And I have to decide excuse me, who I shall select in order to do this, to help me with this problem. Logan!
Oh.
Are you hiding so I wouldn't call on you?
No.
Logan! Are we going to multiply or divide to change this numbers from liters to milliliters?
Multiply.
Multiply, because liters are bigger than milliliters. So we are going to multiply. We are going from liters to milliliters, which means we're going to multiply by
1,000.
1,000. Now, my young friend Logan, when I multiply by 1,000, I move my decimal point in which direction?
The right.
To the right.
Snowboarding.
And how many places to the right am I going to move it, my young friend Logan?
3.
3. So as my young friend Gage told me earlier, if I don't have numbers to move it back, I can add zeros, and that's not going to change my value. So it's going to be 8,300 milliliters. Now I'm aware there are those of you in here that have been absent the last 2 days. So this is new to you.
Me.
Physically absent the last 2 days. And I know some of you have been mentally absent the last 2 days.
Oh, no.
So hopefully these videos will help you improve on how we're doing this. Because tomorrow we're going to go over our last CBA we took. And then Monday we got to start with equations.
Yay.
Really fairly easy.
Equations, Ava. They're easy.
Now for parents watching at home, there are Blurple cards that are due February 8th. And those Blurple cards that are due February 8th have also been posted on Mr. McMurdo 5th grade Facebook page. We have page 495, 496 that is due tomorrow. And if your child doesn't, just sharpen it, oh my goodness. If your child does not bring the book home, they always have them sit down and wait. They always have access on the computer, get on the interweb, and they can go to Think Central and get on Think Central, and it'll have their textbook on there. We've never seen that before in our lives. Well, it's been on Mr. W's board since the beginning of the year. I think the password might be at Keller ISD 123 or at Keller 123 or something like that. Or Keller at 123. I don't know. It's on Mr. W's board. So don't go home and tell your parents you don't know how to do it. Next week we begin with equations. So I can't spend another 47 years working on this. However, there's a chance that during after-school tutorials today, I may accidentally do some of the problems from page 496, 495, or I might accidentally do some problems from the Blurple cards as well. I might accidentally record the tutorials tonight, and so that might be a good place for you to look at that. Also, information on the Blurple cards. If you get them turned in by Monday, I will have them graded, and they will be able to come back to you in your Tuesday folder And then you'll be able to see the grade. You can correct the ones you missed and turn it back in for a higher grade. Because they're not actually due till Feb 8. Feb 8. So you'll have time. Boom! Shakalaka! Peace out! God bless! Love ya! Do something kind today!